Standing over 840 feet long and displacing 45,000 tons, the USS America LHA-6 is not just a ship. She is a floating airbase, designed to carry the Marine Corps' next-generation aircraft, specifically the F-35B Lightning II. She represents a paradigm shift in amphibious warfare, but before she could rule the waves, she was nothing more than blueprints and raw steel at the Huntington Ingalls Industries shipyard. The birth of the USS America begins not in the water, but in the massive logistical centers of the shipyard. Here, the process starts with the arrival of thousands of tons of high-yield naval steel. Before a single cut is made, quality assurance teams inspect every plate. They measure thickness and surface quality to the micron, ensuring the raw material can survive the harsh environment of open ocean warfare. Identification codes are stenciled onto the metal, tracking each piece from the yard to its final location in the ship's hull. Inside the fabrication hall, the digital world meets the physical. Engineers review 3D CAD schematics on rugged tablets, translating complex hydrodynamic designs into cutting instructions. On the cutting floor, automation takes over. Massive CNC plasma cutting machines slide across the steel, generating temperatures of over 20,000 degrees. The plasma torch slices through thick armor plating like butter. The process is mesmerizing sparks cascade as the cutter follows the digital blueprint with surgical precision. But a ship is not a box, it is a complex series of curves. The cut plates are moved to giant hydraulic bending presses under immense pressure. The flat steel is cold formed into the precise curves. Required for the hull's hydrodynamic efficiency, laser gauges verify the curvature instantly, ensuring that the physical plate matches the digital model perfectly.
Shows a slight variance on frame 42.
We should double check that measurement.
Crane, hold position on block 7, wait for alignment confirmation.
Copy that, block 7 secured.
With the components shaped, the assembly begins. In the sub-assembly bays, fitters tack weld the steel plates into frames. These temporary welds hold the geometry in place before the heavy work begins. We then move to the robotic welding cells. Here, automated arms execute long, continuous seam welds that no human hand could match for consistency. The molten weld pull cools to form a bond stronger than the steel itself.
Copy that, descending to target depth.
The defining moment arrives in the dry dock, the keel lane. The first massive module is lowered onto concrete keel blocks. This is the spine of the ship. Alignment is critical. Surveyors use laser theodolites to ensure the keel is perfectly straight, establishing the baseline for the entire 844-foot structure. As more modules are brought in, the hull begins to rise. Workers walk the length of the growing structure, inspecting the fit-up between blocks. It is a mix of brute force and delicate finesse. Once the blocks are locked together, quality inspectors use ultrasonic testing equipment to scan the seams, searching for microscopic flaws deep inside the welds. Only when the integrity check is passed does the skeleton of the USS America officially become a hull.
Easy now, keep it steady. Alignment is good, set it down. Clamps engaged, clear to move.
The USS America is built using modular construction. Giant subsections, some weighing hundreds of tons, are built separately and then moved by self-propelled modular transporters (SPMTs). Watch as the massive gantry cranes, the workhorses of the shipyard, perform the super lifts.
All right, lift team, engage the forward hooks.
Roger that, engaging forward hooks.
They hoist these multi-story blocks into the air and lower them gently into the dry dock. It is a vertical puzzle. Shipfitters guide the blocks into place, locking them with temporary clamps. Before the final welding begins to fuse the hull into one continuous watertight structure.
How's the elevation reading now? Still a hair low. Give it one more solid hit. All right, slowly to the left. Left, got it. Watch your feet back there. Looks good, set it down. Okay, bring her down another foot. Watch the alignment on frame 42. Looks good, set the pins. The welds look solid along this section.
Agreed. No issues with the alignment near the bulkhead either.
Keep an eye on the load coming down from the crane. Roger that, moving to the next section now. The heat input parameters are holding steady according to the charts.
Confirmed. Sign off on the report.
The laser looks good on this side.
Okay, I'm applying the final torque now.
Lowering the platform to level 3. Steady as she goes.
Easy now, watch your clearance on the truss.
Steady as she goes, coming in line now.
While the hull rises, the engineering spaces deep below are outfitted. The USS America uses a fuel-efficient hybrid propulsion system. Massive gas turbines and auxiliary electric motors are lowered onto vibration-isolated mounts.
Alignment is good on the starboard side.
Confirmed, 0.005.
Technicians install the reduction gears and align the long propulsion shafts that run to the stern. This machinery is the beating heart of the ship, capable of driving this steel Leviathan at speeds over 20 knots.
That's 95 foot-pounds. Check the schematic.
Verified on the drawing.
Whiskey 14 is secure. Torque that down another quarter turn. That's good. Hold point confirmed.
A modern warship is more data than steel. Miles of fiber optic cables and power lines are routed through cable trays, connecting every compartment. In the Command Information Center, the ship's brain is installed. Racks of radar processors,
Ensure all
navigation
systems are reading green
computers,
before we
and
finalize the
communication systems
Yes, sir.
are bolted
Power
down
flow
to
is stable according
shockproof
to the
foundations. These systems will track
Bring her
threats from
down
miles
slowly.
away and coordinate air operations in real time.
Watch the alignment on the port side. Okay, lock it in place. Alignment looks good on this side.
Confirmed. Tying down the main conduit now.
Bridge, engineering reports panels on board testing complete. System is fully operational.
Check the specs for the LHA-6 routing. Looks correct. We have clearance on the starboard side.
Check the alignment on auxiliary power conduit, section 4.
Reads nominal here, looks good.
Components secured, finalizing connection sequence.
With the structure complete, the exterior must be sealed. Crews blast the steel to bare metal to remove mill scale, then apply layers of advanced marine epoxy. The flight deck receives a special heat-resistant, anti-skid coating designed to withstand the scorching exhaust of vertical takeoff jets. Then the dry dock is flooded. For the first time, buoyancy takes over. The ship floats free from her blocks. Tugs carefully maneuver her to the outfitting pier for the final touches. The shipyard phase ends and the testing begins. The ship heads to open water for sea trials. The crew tests full rudder turns, pushing the hull to its hydrodynamic limits. But the ultimate test is on the roof. F-35B Lightning II jets perform vertical
Steady the
landings.
course at 300,
Reinforced
maintain
deck
flank
holds
speed.
firm.
Aye,
The
Captain.
aircraft
Course
elevators
300,
smoothly
flank
lift
speed.
the fighters from the hangar bay to the flight deck. The integration is a success.
Hercules approaching from the west. Clear the landing zone.
Roger that. Landing zone is clear.
I want a closer look at that turnbuckle.
Aye, checking now. It's properly seated and wired, ma'am.
Good. Make a note on the tablet.
After thousands of inspections and millions of man-hours, the Navy accepts the ship. The commissioning pennant
Data
is
correlates
raised.
perfectly.
The USS America is ready. From a pile of steel plates to a sophisticated instrument of diplomacy and power, this is the story of American engineering. This is how the USS America was made.
Distinguished guests and shipmates, welcome to the commissioning of the USS America. Today, we bring this great ship to life